versus just like, standard run-of-the-mill like Ubuntu like out of the box, right? So I went through some of the defense mechanisms that I know about and discussed like, really briefly like why they're good or why they're bad or whatever. So I'm sure you guys know about the NX bit, the no execute bit. That's cool, but if we just load our DSO and our DSO can just call mprotect and just say, hey, this page that was, not execute, just make it execute. So that doesn't really help us. You can strip out debug information, but most people just use pre-built binaries. Most people just use whatever comes with their distribution of Linux. So I can just like I can just get that VM, I can download the debug symbols, and I can figure out all the offsets myself. You can statically link everything if you want, and then you still have the problem of getting overwritten otherwise, but you don't have to worry about your global offset tables getting poisoned. The problem with that is your binaries get pretty fat. You can put all text code in ROM. That'll probably work. I don't know. I mean, perhaps there's like some really crazy legacy C code that if it's put in read-only memory will actually die. But in theory, that's supposed to work. So that would actually work. You can also not load DSOs at runtime. The problem with that then is you sacrifice any and all plugin architectures that are out there. You can disable ptrace, but ptrace is pretty sweet. And if you disable ptrace, you lose GDB and you lose strace, and both of those are really fucking useful. You can also check procpid maps. That works. So if you watch procpid maps all day long and somebody injects a library in, it'll appear on procpid maps, and you can see like, hey, this whatever evil.so is now running in my process. So that would actually work. It's just kind of painful to do that. So anyway, sort of looking forward, like on more experimental stuff, I think for me personally, my future research is going to be sort of geared toward exploring alternative binary formats and like other crazy things you can do. So just to recap, we talked about 3 different binary patching techniques. These techniques leave the original binary in working fashion after they're done. So kind of like teeth whitening, right? Like you can still eat food after you're done, it just looks a little different, same deal. And there's 3 things that matter, right? There's alignment, calling convention, and object file and library formats. And before I end this, I actually had a couple extra slides of something really weird I found that I wanted to share in case I had some extra time. So look, an alien baby. And I saw this really crazy post to a mailing list. The title of the post was Interesting Behavior on OSX. This was written by a guy named Stephen Edwards, November 29, 2007. This is the link to the actual mailing list post that he wrote. It turns out that Leopard actually has a PE loader, which is really weird. So if you execute this code on a Leopard system and you try to load a Win32 executable, you get this output. So for whatever reason, there's a loader for Win32 binaries on OSX. So even if you had all the Windows DLLs in place in the right path so everything could be found, it wouldn't actually work anyway, right? Because all the APIs are different. But it's still sort of curious, like why the hell is there a PE loader in OSX? So I don't know if anybody out there knows the answer to that question, but definitely something to check out if you guys are looking to play around with something weird. I think this is now disabled. I tried this recently on Snow Leopard and it didn't work. But I remember trying this a few months ago on Snow Leopard and I thought it did work. So I'm not really sure what's going on with that, but it's pretty bizarre that there's a PE loader in Leopard. Anyway, thanks for coming. And there's a bunch of links at the bottom. If you get this talk online and you want to read more about some of this stuff, I have a bunch of blog posts describing each of the binary patching mechanisms in much more detail. But thanks for listening, guys.